What's up, kiddos? Unit 1, integers. This is your intro and your first lesson all wrapped into one. So follow on carefully, and if you need to stop and go back or forward, you can take care of that to your own liking. So let's go ahead and walk through this. This is Unit 1, integers. So let's break down what integers are in a way that we can really understand what's going on here. So the first thing you have to understand is we have natural numbers. So naturally, when you are a little baby and someone says, oh, do you know how to count? Can you count for me? Ready, set, go. You go 1, 2, 3, just like that. Naturally, when you're a little baby, okay? So those are called natural numbers. They're your like counting numbers. Later, just for fun, we decided to add this phrase, whole numbers. Now, whole numbers are the natural numbers with a 0 attached. So you learn that, oh, that 0 actually exists here. So it was 0, 1, 2, 3, and so on, okay? Then you get a little older, and we have 0, 1, 2, 3, and their opposites. So we have -1, -2, -3, and so on, okay? And so that's the breakdown. So just remember that so that you have an idea of what integers are, but also how we build to then understanding integers from natural whole integers. So let's go ahead and move down here. We'll take a look at an intro to this unit. Let's start off by putting the date here, and we're going to be doing comparing and ordering integers. This is 1-1. Don't worry about a page number here unless you want to be numbering your pages. Our learning goals that we're going to be doing today are learning goal number 1, 2, and 3. So go ahead and put those in, and I'll explain what the learning goals are later. So basically in this unit, we're going to be comparing and ordering integers, adding integers with a number line, subtracting, doing order of operations. NIB means is not in the book, whereas this is where the particular skill is in the book. Multiplying and dividing integers, order of operations, like PEMDAS, with integers, and word problems with integers. And so let's go ahead and move down here. Now we'll talk about the standards and then those learning goals 1, 2, and 3 like we talked about up above. So the state standards here are basically the state says, hey, if you're in 7th grade, these are the things you need to know. So you can see the 7 here, that's for 7th grade, and then these are just other categories. So look through those, you can see what our overall objectives are for this unit. The related book sections. You have your book at home. If you need to reference anything or look up some additional problems or anything like that, this is where you find it in the book. All right, here are our learning goals. Specifically for today, we're looking at learning goals 1, 2, and 3. So let's look through all of them and then we'll get started. Learning goal 1, I'll be able to compare and order integers, being able to add opposites. We have being able to find the absolute value of numbers, add integers using chips, a rule, and by number line. We have subtracting integers, write equivalent numeric expressions, evaluate order of operations expressions involving whole numbers, and then later we'll do that involving integers, multiply and divide integers, and solving real-world word problems with integers. So let's focus on number 1, 2, and 3 now. This is your vocabulary section. So we list the vocabulary for the unit, its definition, and then where it's located in the textbook. So you can see other than the not in book pieces here, you can know where to find that information. All right, so shifting down here, you can see our key concepts. This is your actual 1-1 comparing and ordering integers lesson. So what I want you to be doing if you are watching this from home is you should be having the Notability open with this particular lesson and copying it down exactly from this video. So pause as necessary so you have everything you need. Make sure you're being neat and writing things exactly as I'm showing you on here so you have all the correct information to study from later. All right, looking at your vocabulary here. The first one is whole numbers. You can see whole numbers are all counting numbers from 1 to infinity, including 0. So to go back, remember we have natural numbers, like a little baby going 1, 2, 3. Then we add the 0 to make whole numbers. And then we have integers. And integers are the set of all whole numbers, like we just highlighted, their opposites, so the negatives, and also 0. So let's go ahead and start filling some things in here for these key concepts. So whole numbers, like we said, are the 0 and 1, 2, 3, and so on. So we use the 3 dots or ellipses to show infinity. And infinity is a sideways 8 symbol, but the ellipses actually represent that. All right, and then on to integers, we said it's the same thing as the whole numbers there, but it is their opposites as well. So we have dot, 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 because everything infinity to the negatives. Negative, for space-wise, let's just do -2, -1, 0, and then we have the opposites of 1, 2, and ellipses to say that that goes on forever as well. Okay. Our next key concept is additive inverses. And what I want you to think about with additive inverses is just sort of like break this down. Okay, we're using the word add here. And then inverses, like we talked about with the integers, the inverse of 1 is going to be its opposite of -1. So we're adding inverses, and that's what that means. So an example here would be the number 3. And I want to add its inverse. So what is its inverse or opposite? It is a -3. And we understand that that's the same thing as 3 minus 3, but we're writing it like this. So you understand that when we're doing 3 minus 3, we're actually doing 3 plus a -3. Okay. All right. And let's just put this in parentheses to keep it separate. Okay. Let's show another one with another number. So we'll just pick 6, add the inverse. So the inverse of +6 is -6, and there we go. Let's go ahead and do the commutative there, just so we're showing a couple different ways. So if I did a -7 first, and I add the inverse, well, what's the opposite of -7? It's +7. And so the thing for you to notice is if I do add those together, a +3 and a -3, they're going to equal 0. +6 and -6, -7, +7, they all equal 0. So the added inverses always are going to equal 0. So just be aware of that. We're going to be using that today. The last one is absolute value. So what I want you to think about, let's say I am 30 feet underwater gasping for air. Oh, help me, help me, help me. I can't get up. So I'm -30 feet below water. If I said, how far do I need to go to survive and get air? You would tell me that, oh, well, you need to go 30 feet up to get air and survive. So that's essentially what absolute value is. We're saying, how far am I away from 0? Even if I'm -30 below sea level or something like that. You can sort of picture an elevator because that's actually what absolute value looks like. So if I say the absolute value of 3, I'm saying how far am I away from 0? So absolute value of 3 equals 3. What if I said this? What is the absolute value of -3? So again, I'm still asking you, how far am I away from 0? If I'm -3 feet under the water and I'm needing to get up for air, or I'm -3 feet below in a hotel on an elevator, how far do I need to get back to the 0 level? I need to go 3. So basically, absolute value just means ignore the negative. The negative doesn't exist. How far am I away from 0? You just look at the number and write the number. All right, let's do another scenario here. What if I say the opposite absolute value of 3? Okay, so I do something like this. So we focus on what this means, okay? And this little negative here, let's go ahead and zoom in a little bit more, and I want you to write opposite. Okay, so opposite of the absolute value of 3. So first of all, what's the absolute value of 3? It's 3. What's the opposite of it? It is negative. So because that negative symbol is outside of the absolute value, that's how we think through that. One more situation here. Let's do what is the opposite of the absolute value of negative 3 equal. Okay, and so something like this, again, here's how you read this. We're going to go ahead and write opposite. So what's the opposite of the absolute value of negative 3? Okay, so first of all, if I'm negative 3 under, how far am I away from 0? Well, I'm 3 away from 0. So what's the opposite of that now? The opposite is negative 3. So that's your only way that you can pull off getting a negative when you see absolute values, is if that negative or opposite sign is outside of it. The last thing I want you to see is, well, I guess we'll look at some ways that people might trick you with absolute values by using parentheses instead. So let's go ahead and look back up. You can see in your vocab here, it does say that absolute value is the distance from 0, whether it's on a number line or in a vertical number line or whatever the situation is. So that's absolute value. We already looked at the additive inverse, which is two numbers whose sum always equals 0. We are going to look at this word evaluate in a little bit here. So let's go ahead and look at our next one. Our next example is opposites. And when we're looking at opposites, we're talking about they are the same distance from 0 on a number line, but in opposite directions. So it's their inverses or their opposites. Okay, and so let's go ahead and solve these. So what's the opposite of negative 8 is 8. Opposite of 13 is negative 13. Opposite of negative 22 is 22. Okay, nice and simple. All right, the additive inverses. Let's go ahead and look at what that says. So additive inverse, remember, is two numbers whose sum is 0. Okay, and so we have negative 5 plus a positive 5 is 0. The sum of all additive inverses is always what? 0, because it's two opposite numbers put together. Okay, they're the same distance from 0. All right, next one. We see this word evaluate here. I'll use the highlighter. When we're evaluating, here's what that means if we look up at our vocab. Evaluating just means to find the value of an expression. So essentially solve it, but there's no equation in these particular problems. So here we go with evaluating. So what is the absolute value of 14? How far am I away from 0? Well, I'm 14 away. How far am I away from 0 if I have a negative 5? So what's the absolute value of negative 5? It's just 5. Absolute value of 24 is 24. Now, remember this right here. The negative outside actually means what is the opposite of the absolute value of 33. So absolute value of 33 is that. What's the opposite? We attach that negative on there. All right, so now remember here we have what is the opposite of the absolute value of negative 7. So start with the negative 7 first. Okay, so absolute value of negative 7. If I'm negative 7 underwater, how far do I have to go? I have to go 7. What is the opposite of that? Is negative. We just bring that down. All right, now this is where they're trying to trick you because these are not absolute value symbols. They are parentheses. And so what is negative 54 in parentheses? It's still negative 54. Remember, this means opposite though. Okay, so what is the opposite of negative 54? The opposite of negative 54 is positive 54. Okay, so realize this also, just so we're this is a little preview, this also means negative 1 times negative 54. And when we do a negative times a negative, it does equal a positive like we got. Okay, all right, on to example 4, comparing integers. Okay, when we're comparing integers, we're using those comparing symbols. Okay, these are called inequalities, which meaning they're not equal to each other. And so first thing you have to do is understand what these inequalities actually say. So just remember, if you're reading something, okay, like this, whatever you are writing, when you're reading something left to right, okay, this is how we read books, is left to right, whatever is the bigger side that you hit first, okay, or whatever side you see, like I see this bigger open side, that means greater than. If you're reading it like this and you're reading left to right, the thing you run into is the smaller side first here, okay? Then we say less than. The other thing that you've seen is like the alligator eating the bigger numbers and things like that. So whatever works for you to remember and do it right, that's all that matters, okay? All right, so let's think about these integers here. So we have -7 and we have +9. When you're looking at those numbers, we understand that +9 is bigger. Okay, so -7 is less than. I make the smaller part be what hits first when I'm reading left to right, less than 9. Okay, over here we have the absolute value of -5. So go ahead and evaluate that. So that actually just means 5. Okay, because we're asking how far are you away from 0. And so 5 is equal to 5, okay? Or the absolute value of -5 is equal to 5. This one just messed up a little bit, so I'm going to make some white here. You can do the same if you want and sort of white this out. Let's go ahead and do that for a moment. Now that that's whited out, I can go ahead and I'll use black here and fix it, whatever it said. Now I don't remember. Negative absolute value of -4. Okay, so let me get my white back here, nice and big. Guess I should have wrote it first and then whited it out, but all right. So here we go. Let's go ahead and rewrite that. So what is the opposite of the absolute value of -4? Okay. So let's go ahead and take a look at that. The first thing I see, let's take care of the parenthesis one, is we have the opposite of -4. So the opposite of -4, or -1 times -4, is +4. Okay, the opposite of -4. Now we have the absolute value. Always address the absolute value first, then the opposite symbol. Okay, so the absolute value of -4 is 4, and then what's the opposite of that? The opposite of that is -4. So now we have +4 compared to -4, and I know +4 is larger or greater than -4. Last one, we have -17 and -23, and I want you to think about temperature here is the best way to compare negatives. So which one is colder? Is it -17 or -23? So that's the one that's less. So if you were outside and you're like, oh, it's -17 out, and someone's like, oh my gosh, where I live, it's -23 out. So which one's colder? That's the one that's the less sort of temperature. So that means -17 is greater than -23. So you have to really think through that slowly before you tackle that. All right, the last one section down here is all about comparing and ordering and plotting on a number line. So let's take a look at this. Again, we see that word evaluate, okay, which just means solve essentially. So let's go ahead and do these. -5 doesn't need evaluated. There's nothing to solve or change. So I'm just going to write -5 and copy it down below. -11 does not need evaluated, so I'm just going to put that down here. But letter C does, okay? We have -9, and what is the opposite of -9? Okay, and notice those are parentheses. So go ahead and put that down, and then you can see if you're right. So I have the opposite of -9 is just 9. Okay, or you can think -1 times a -9 is also 9, because two negatives multiplied, negative times negative equals positive. All right, absolute value of -5. How far am I away from 0? I am 5 away from 0. And then what is the absolute value of 0? How far is 0 away from 0? Not very far, 0. All right, time to order these from least to greatest. So I need to find the smallest one first, which means sort of temperature-wise, the coldest. So I see the coldest would be the -11. It's the coldest sort of temperature I have. So I'm going to put that here. Be aware, it says the original one. So I can't write the new evaluated number. I need to officially write the original, but I'm going to use the new one to help me know what that is. All right, I see another negative number. Okay, so that's the next sort of coldest. And now we have 0, but I'm going to write the original statement there. And then we have 5, but I'm going to write the original expression. And then we have 9, but I'm going to write the original expression that we saw. Okay, so these are all numeric expressions because they don't have any variables in them. All right, and then we have to do our final thing, which is plot each integer on the number line below by using a point and the letter provided. So again, I'm going to go back up to here to help me see my orders, just to make things easier. But again, I have to then look at the number that goes with it. So let's go ahead and start from least to greatest here. Or I guess it doesn't really matter. I can just go ahead and order with this. So -5 is first. So let's see. I got to try to figure out these intervals. -3, -4, -5, -6. So I'm going to plot a point here, and then I'm going to label that A. So that's my -5. Next, let's go ahead and do B. B is at -11. So I have -9, 10, 11, and 12. So -11 is here, and we're plotting point B. Now we're on to point C, which is 9, and that's right there. And then we have point D is 5, so we have 4, 5, 6. I'm going to go ahead and plot my point for D. And then we finally have E, which is just 0. So let's plot our point for 0 and label it with E. All right, that's it for our notes for the first lesson. And then make sure you exit out of your Notability, and you can check back for the next lesson in the next video.